Hi everyone, it's my honor to present our work on From Lost to Found, Discover Missing UI Design Semantics through Recovering Missing Tags. Tagging is to summarize the content with several compact keywords, like collaborating tagging helps users to filter and retrieve relevant content, and the system distributes the work of categorization across the entire community. As one of the largest network design sharing platforms, Dribbble also uses a collaborative tagging system and allow users to tag their designs when sharing. Like here, users can add tags. To explore and improve the collaborating tagging system, we conducted an empirical study of design sharing. Firstly, what are designers sharing? Within the Dribbble site, the design creators can add at most 20 tags for their design work. These natural language tags convey the semantic of the design. We adopted the association rule mining and community detection for visualizing the landscape of collected tags from Dribbble. In this graph, a set of highly correlated nodes is referred to as a community in the network, and we visualize different communities with different colors and the nodes with higher frequency as large size. It can be seen that there are many communities related to GUI design. Therefore, UI design is of great importance in design sharing sites. Mainly focused on UI designs, finally we summarized the 26 categories and 5 main semantics: platform, color, app functionality, screen functionality, and screen layout. The table shows the tag list of our dataset. During the design collection, we found that there were two main tagging issues within the sites: inconsistent vocabulary and missing tags. First of all, English words have many morphological forms, like abbreviations, synonyms, and misspellings. For example, user interface is always written as UI, mobile and phone has the same meaning, and word visualization sometimes can be misspelled as visualization. And the second one, some UIs are missing related tags, which makes them unsearchable. We got some feedback from informal interviews with 4 professional UI designers from Google and Huawei. A visual designer from Huawei mentioned that he didn't intentionally use the semantic words to annotate his design works, and he didn't know much what tags are there and which tags to use. Instead, he attached his UI design with some fancy tags like 2019 training to make his design more attractive. And designers from Google point out that some UIs are missing relevant semantic tags. For example, we can get a lot of retrieved results when searching yoga, but few in yoga website. Meanwhile, designers may adopt different words in the same meaning to tag a design, like travel and trip. Targeting these two issues, we trained a set of binary deep learning classifiers for 26 categories using visual and textual information to augment tags. Here is our model architecture. ResNet backbone was used to capture visual information, and a pre-trained model and a 2-layer CNN were trained to extract the silent textual information. For the results, we achieved 82.72% model accuracy, and was a big improvement compared to the baselines. The figures illustrated the predicted additional tags and realize the silent features. We can see that these additional tags can complement with the original ones for more effective UI retrieval. To further evaluate the usefulness of the predicted additional tags for bootstrapping the UI design retrieval, we conducted a pilot user study. 10 master and final year bachelor students from ANU were recruited to rate 1 control group and 3 experimental groups in 5-point Likert scale. Here is the test query and number of the retrieved images from 2 systems. And here is the result. We can find that our system can retrieve many more related candidates and provide more satisfactory and diverse designs. Last but not least, I will summarize our contributions. First, we did an empirical study of design sharing sites. Second, we developed a deep learning-based method for recommending missing semantic tags. Finally, we conducted a user story showing the usefulness of predicted additional tags. The source code, experiment results, and analysis of the user study are released. Thanks for listening.